Welcome back to Chem Help ASAP. In our previous video, we used our orbital energy diagram to specify where our electrons were in the atom. Now, this is really helpful when you want to visualize how orbitals are added and what orbitals are higher and lower in energy. However, as you saw, these diagrams get really large and they get very cumbersome to use. So in this video, we are going to introduce a new way to specify which orbitals are occupied in an atom. And it works so much better, especially when we have a lot of electrons in the atom. Now, in this video specifically, we're just going to focus on our s orbitals and our p orbitals. My next video, we will focus on d's and f's. Before we jump into our new way of doing electron configurations, I want to make sure you understand the connection between the energy diagram and the electron configuration. So we are going to start with our energy diagram and we're actually going to transfer that to an electron configuration. So we'll start with an easy element. Let's start with nitrogen. Now, nitrogen has 7 electrons. Just like we did in the previous video, we'll start with the 1s and we'll just fill 7 electrons. So I have 1, 2, 3, 4, 5, 6, 7 electrons. Now the way we're going to write this out is we're going to tell the reader what orbital we're talking about and how many electrons are in that orbital. So we started with the 1s orbital. There are 2 electrons in there, so I'm going to denote that with a superscript. The next orbital I filled was the 2s orbital. Again, I have 2 electrons in there, so I'm just going to do a superscript of 2. Then I have the 2p orbitals, and right now I have 1, 2, 3 electrons in there, so I'm going to simply put a 3 as a superscript there. Now you can automatically see one of the disadvantages to writing the electron configuration this way is it doesn't show you graphically that those are unpaired electrons because we have condensed everything down. And while this is a simpler form, we have lost a little bit of information. Now, one thing cool that I want to show you is that you can still count up your electrons to make sure that you have accounted for all 7 of those electrons. So I am going to switch to my green, and notice if I add 2 plus 2 plus 3, I get my 7 electrons. So this is always a nice double check to make sure that you have a reasonable electron configuration. If I added my superscripts and I got 20, there's no way that could be a correct electron configuration for nitrogen. Now that we have connected the orbital energy diagram to our electron configurations, I want to connect the periodic table to our electron configurations. So the first thing I'm going to show you is where the s orbital electrons are and the p orbital electrons are. These first 2 columns are your s orbital. The 6 columns over here on the right are your p orbitals. Now, notice I did not put helium in my p orbitals because, of course, its electrons are not in the p orbital. Depending on the periodic table that you are using, you may notice that helium is over here next to hydrogen, or some periodic tables will put helium in both places because it can go both places. Because remember, helium has 2 electrons and they both go in that 1s orbital. The other thing I want to show you are these numbers here on the far left from 1 to 7. These are actually your principal quantum numbers. They correspond with each row, or on the periodic table we call it each period, that moves from left to right across the periodic table. And these numbers will tell you which s orbital or which p orbital you're talking about. I think the best way to pull all these concepts together on the periodic table is just to do electron configurations. So let me change color, and let's do the electron configuration for lithium. Lithium is right here. Based on its atomic number, I see it has 3 electrons. When using the periodic table to do electron configurations, I'm always going to start with hydrogen because I'm always going to start in the 1s orbital. So 1s, and then the question is how many electrons? Well, I have 1, 2, and then of course after I have those 2 electrons, I need to move down to the second period or the second row. That means I am now in the 2s orbital. And for lithium, I only have 1 electron. I'm going to clear the periodic table. Let's start over and let's do the electron configuration for oxygen next. Okay, oxygen. Oxygen is right here. 8 electrons. I always start with hydrogen. Hydrogen is the 1s orbital. I have 2 electrons there. Now I go to my second period, so I'm in the 2s orbital. 1, 2. I'm not to oxygen yet. When I switch over to boron, notice I'm switching from the s orbitals in the first 2 columns to the p orbitals. I am still in the second period though, so these are the 2 p's, and I'm just going to count across to oxygen. 1, 2, 3, 4. I have 4 electrons in the 2p orbital. Now for my double check, I'm going to add up my superscripts and make sure I have the correct number of electrons. So I have 2 plus 2 plus 4. Yes, I have 8 electrons. Let's clear everything out again, and let's do magnesium next. Okay, magnesium. Again, I always start right here when counting across. That is my 1s orbital. 1, 2 electrons. Switch over to my second row. This is my 2s orbital. 1, 2 electrons. Once I switch over to the right-hand side of the periodic table, I am now in my 2p electrons. 1, 2, 3, 4, 5, 6. I am finished with that row, but to get to magnesium, of course, I need to move on to my third row here. I'm back in the s orbitals, but now I'm in the 3s orbitals, and I have 1, 2 electrons there. Again, magnesium, I check the atomic number, 12. So let's add up 2 and 2 and 6 and 2. Yes, I have 12 electrons. So therefore, I can be confident that this is the electron configuration for magnesium. Now, you can probably already see that if we are going to do electron configurations for atoms with many electrons, say we were going to do francium down here, our electron configuration is going to get very long. So I want to show you a shortcut. So I am going to keep the electron configuration for magnesium up there, but right next to it I want to do the electron configuration for neon. So neon, let's see, that's 1s, again 1, 2. Go to my 2s, 1, 2. Now I need to switch over to my 2p. 1, 2, 3, 4, 5, 6. That puts me at neon. And there's my electron configuration for neon. Now notice that neon's electron configuration is actually embedded in magnesium. Let me switch colors to make this a little more clear. So you can see that that electron configuration is exactly the same as neon's. So I am going to rewrite the electron configuration for magnesium, and I am simply going to substitute in neon, and then what's left on the outside, that is 3s2. Notice how much shorter that is. This is called the noble gas shortcut. So to use the noble gas shortcut, of course, you must use a noble gas. Here are your noble gases. On the far right-hand side of the periodic table, you must use one of those. You cannot pick and choose which element you want to use. You must use a noble gas. It must be a noble gas that has fewer electrons than the element that you are giving the electron configuration for. So I'm going to clear the periodic table off again, and we're going to do an example of this. Okay, back to a clear periodic table. Let's take the example of chlorine. So just like with my other examples, I'm starting in the 1s orbital, 1, 2. Move on to the second period, 2s, 1, 2. Come across to the 2p, 1, 2, 3, 4, 5, 6. Moving on to the third period, I'm back in the s's, that's 3s, 1, 2. Come across here, now I'm in the 3p's. And to get to chlorine, I'm going 1, 2, 3, 4, 5. Here is the electron configuration for chlorine. Now, to do the noble gas shortcut, it is very, very tempting to use argon. But the problem with argon is you cannot find the complete electron configuration for argon embedded in chlorine, because what is the electron configuration for argon? Argon has one more electron than chlorine. So it would be 1s2, 2s2, 2p6, 3s2, 3p6. So even though it's only one electron away, it is one more electron. That is the key. To do the noble gas shortcut for chlorine, we have to go back to neon. And again, I will find neon's electron configuration right here. So I can rewrite my electron configuration for chlorine using neon. And there it is. I have often seen students struggle because they are trying to memorize the order of the orbitals and the electrons. And what I would encourage you to do is just learn how the periodic table works, and it will tell you the order of the orbitals and how many electrons you have in each of those orbitals. I am such a fan of the periodic table. I know, I'm a little weird.
Now that we are comfortable with electron configurations for the s and the p orbitals, we're ready to tackle the d's and the f's. So check out my next video where we're going to deal with larger atoms and more electrons.